All right, everybody, and welcome back to the repair bench. What is your problem? This cat acts like I don't feed her. Look how big this thing is, and she's just all over me right now. Anyway, okay, getting back to this. This Miss Pac-Man set is my friend Todd's board set. He's putting a Miss Pac-Man together and asked me to take a look at this board because it's not working. And right off the bat, when I flip it over, I see some jumper package there. So I am going to remove all of these sockets and inspect everything. I normally don't like to do that, mess with boards like this, but this is my friend Todd's, so I'll go through it. I'll probably remove these sockets too, and clean everything, because Midway, this stuff with Midway stuff is really, that one looks, yeah, this stuff needs to be removed. I'll replace this guy, and if these have not been replaced, they have, so I'll have to look at that too. And yeah, just have to go over, see what's going on with this thing. So first things first, I am going to remove prior work. That's the first thing I'm going to do. So let me set up, and you know what, I don't think I'm going to bore you with that. I think I'm just going to go ahead and remove everything, and then I'll come back and we'll take a look at it and see what see how everything looks. Okay, I have finished removing these sockets, and I only find, on the top side anyway, I find two bad traces, and one of them is right here from this via to that pin, and this one was already repaired. These were already repairs that were done. And this is the other one, going from right here over to here. That's broke right there. Now I'll have to flip it over and go over the back side of the board, which is a lot worse. The back side of the board is really terrible. So we'll go over that next. Okay, and upon inspecting the rear side of the board, you can see there's every pad missing up to here. That's broke. This trace right there is broke. There's a bunch of broken traces. That's broke. And there, and then coming over, that is, actually there's continuity there, but it looks broke, so I'm gonna repair it anyway. And over here I don't see any, it's just some missing pads. But yeah, the CPU area is really bad. You know, I have to repair that trace right there is broken. All these pads are missing. It's broke right there. Yeah, so got my work cut out for me on repairing. After I removed everything, I took with some alcohol and really scrubbed it good to clean up, because you got to be able to see what you're doing, what you're working with. If you have flux left on the board and stuff, you can't really see what you're working with. And I did beep these guys out. Those two ROM right there, those two sockets were fine. I beeped them out and they're fine. So we'll repair everything needed to be repaired up here, put new sockets in, and go from there. Okay, so I have finished with the sockets. I got the sockets all put in, and I got the fluke hooked up to it because I was doing RAM and ROM checks to basically check my work, my repair work on the socket problems. And I'm getting to the ROMs, no problem. They all verify, they all, no problem. Where I'm having a problem is when I go do RAM. We'll do a RAM test. And you'll see it will give me bit 7 bad decoding. See, decoding error bit 7 every time, any range. So I'm gonna have to look at the schematic and find the bit 7 there. And if I do a run, this is a clue here too. If I run UUT and then look at it, in the screen I'm getting columns, and this column is the same as this column. And then these two are the same, so that tells me that there's in the horizontal and vertical line generation, there's a problem, is what that's basically telling me. And I believe that'd be horizontal problem maybe. So I'll have to look at the schematic and look at those 161s that make it's either horizontal lines. I'll have to check that out and look at my horizontal counts, because that'll mess up my decoding too. So yeah, let's do that. We'll go ahead and I think it's just these guys down here, but then there's flip-flops involved and stuff. So I'm going to look at the schematic and go from there. Okay, well, if you remember, this was giving me a bit 7, address bit 7 decoding error. And so I just decided to probe with the oscilloscope up here some address lines, and over here where they're buffered out, bit 7 was floating. There was a broken trace right at this chip. So I had to remove this socket, fix the trace, and put the socket back in and fire it up, and it has decided to start working somewhat, but we still have a positioning problem. So there's still something going on. I think what I'm going to do right now is I'm going to put the fluke on it and make sure that I'm good with the RAM. The RAM passes the video RAM and Sprite RAM and all that kind of stuff. And then we'll go from there. In the video section over here, there's some muxes. This looks kind of like a muxing problem to me. Yeah, a muxing problem, and adding problem of some sort, or something. So yeah, just for S's and G's, I'm gonna go ahead and put the fluke on it, verify all my RAM and ROM is accessible and passes every time, and then we'll move on from there. Then I just believe it's a matter of this section right here. There's some muxes, there's some 157, 158 muxes and stuff like that, and I believe that's where my problem's going to be. So, all right, that'll be the plan of attack. Go ahead and throw the fluke on it and see how that looks. And one thing I did do too is this thing is having a weird startup problem where the clock doesn't start when you start it sometimes. So what I did was I replaced this guy here. I replaced the crystal and the 100 picofarad capacitor right next to it. That the clock goes through this through this guy right here, back into this. It goes out, back in through this capacitor, back in, and oscillates. And it would just hang up and not work sometimes. So I replaced both of these components and it seems to have fixed it. So that'll be I'll just keep testing that, but it seems to have repaired that part of it. So I'll go ahead and put the fluke on this guy and see how we're looking. And guys, I just wanted to clarify why I could put the fluke on and get to my ROMs good and verify all my ROMs, but I couldn't get any further than that, is that address bit 7 trace made it to this ROM. It's pin 1, but on the opposite side of this pad, where it goes this way, down to here, down the line to these buffers, is where it was broke, right under this. Like it made it to there, but it did not advance from there. So I was able to do all of the ROMs, but I couldn't go beyond the ROMs. So yeah, this is what we're doing. And I did one thing right off the bat because I wanted to eliminate it as a problem. Was I went and I removed both of the 7489 video RAMs and I replaced them and got the same thing. So I just put the ones that I took out of the board back in the board. It's not the RAMs. So I wanted to eliminate the RAMs as a problem. So I'm going to look at the schematic and find out and get a good educated guess as to where to start looking. I'm going to look at something that deals with addressing. Somewhere that the address bits, or either the address bits or I believe that would be the vertical lines. Yeah. Or is that is the vertical lines, I believe. It's hard for me to decipher when looking at this. Horizontally, I believe it's okay. I think its vertical position of stuff is messed up. That's what it is. It's the vertical position of things is not right. So wherever my vertical lines are going, either that or address bits, something like that. So that's what I'm going to be looking at the schematic for and finding. So let me do that. I'm just going to check it over and get an idea, and I will be back. You see, I got my schematic printed out here, and I've been looking it over, but I did want to add one thing. I did hook the fluke back up to this, and I was passing all my RAM checks. I was doing actually long RAM checks on these, which is much more involved. And they passed with flying colors, no problem. So the CPU side of things is done. This is just purely a video generating failure on the board now. So, and like I said, I've eliminated these 2 RAMs as a problem. So it's something other than these. And I'm looking through the schematic right now, and I'm looking for vertical lines either being muxed into something or being processed somehow. So that's kind of where I'm looking right now. And when I find something, we'll look at it together. Okay, so I am starting to go look at some signals on this board. And I'm hooked up to the vertical counters. These are the vertical line counters, which in the schematic are right here. So I am looking at 1V, 2, 4, 8, 16, 32, 64, and 128V. That's what I'm on. And the highest bit of the count is vertical sync. That's the last line, vertical sync pulse right there. But as you can see, these vertical counts look perfect. That's vertical, that's 1V all the way down to vertical sync pulse. So there's no problem here. It's after this. Our problem is after these guys. So I'll keep looking at the schematic. I put this schematic together. I printed it off and I taped it together. Kind of made it nice at the seams. So I have a nice Pac-Man schematic to go over. I have to use this to look at it, but that's okay. So I'm going to move on from here. I'm going to find those, and I believe a lot of the I'm going to pick up right here, I believe. See these vertical lines going into these adders. But I think I'm going to look at these adders next. We got adders, and then we've got there's a couple of latches, mucks. I'll have to look at all that stuff. So I'm going to look at those adders next, and they're right here. There's adders and there's counters. And this looks like a count issue, really. If you really look at it, it really kind of looks like a count issue. But we'll start at the adders. I'll look at the adders, move on to the counters, the latches that are involved and stuff, and we'll track it down. Alright guys, here's a little trick that you can do to help you narrow down your issues. I have removed these two RAMs, set them aside, and I wanted to see what this thing does without these two RAMs in it. And those two RAMs are Sprite RAMs. You remove those, there are no sprites at all. See, there's no sprites, no Pac-Man, no ghosts, moving objects. And all that's left is characters. So this is a character problem. And what I think this problem is shift registers. Because I've seen this before, this kind of junk. With the high scores and stuff like that. Like, let me reset this thing, and you'll see really quick. Okay. In the screen, the grid pattern, see that? In the grid pattern where it has little squares, in the squares, whatever, I've seen that in a Galaga before, and it was a bad shift register. So I think that's my problem here, and there are shift registers right here in the character section. This is not a sprite problem. Anything involving these RAMs with the sprite data coming down through here, I think this is purely a problem up here. So I'm going to start with these two shift registers, I believe. You know what, I could start at the very beginning of the character process. Start with the addressing to these guys, and then the 8 bits come out and they're shifted in these two shift registers. I think that's where the problem is. But I'm going to start at the beginning, start with how these are addressed, and go from there. Because we've eliminated sync problems. It's not a line problem. It's a generation problem. We've eliminated sprites. It's not a sprite problem. It's a character problem. So, yeah. I'm going to turn it off, put the RAMs back in it, and we'll start going over that schematic and look for a character where the character stuff is started, and we'll start there and move out. Okay, I am looking at a 157, which is this guy right here. You can see it is the mux right before the output stage. Red, green, blue. And this guy right here is not working correct. I have a snapshot right here. This is the select line. And then we have 0 input, 1 input, and then the output. You can see it's selecting 0, 1, 0, 1, 0, 1, you know, kind of alternating. And the output should match what it's selecting. And you can see here it's selecting 0, which is high, and it stays low. Then it's selecting 1, which is high. So we're missing all of this, all of these pulsing, all of this pulsing right here is all completely missing. I will go ahead and just kind of run this thing, let it run, repetitive. And you'll see for the most part, it catches some of the pulsing, but not all of it. And it misses a ton of stuff. So this thing does not work correctly. It's sending some of the pulsing down, but not all of it. So this one's definitely not working right. I'm gonna go ahead and analyze the 158 right next to it, and then we'll take a look at that one too. I looked at this 157 here, which is this guy on the schematic, and it's fine. But this one's definitely bad, and I'm going to take a look at this guy right here. Okay, now I'm on this 158. And if we take a look at the snapshot I have up here, you can see the same thing. It's selecting 0. Now this is an inverted output, so it's going to be the opposite of... See here, it's right. It's selecting 0. 0 is low, so the inverted output will be high. But here we should have low pulses, and we have nothing. So this one isn't working either. These two muxes right here do not work. And it's these two guys right here. Just kind of taking a peek at what is going on here. That's the final output stage right there. And this one is sending the data back to these buffering RAM. And that is a 377, which is getting the I'd have to actually study to find out what's going on. I can't just take a quick peek at it. I'm just poking around in the video section. But this is the output stage, basically. And to be honest, I don't see where these would cause this type of problem on the screen. But they're definitely not working right. So I'm going to replace them both. But I'm not 100% sure that's going to fix the problem. That might fix a problem, but it's just strange. I don't know. Well, anyway, I'm just going to go ahead. These are definitely not working right, so let's go ahead and replace these two guys. Okay, I am now looking at the 283s, which are these guys right here. There's two of them, 283s. And they are involved in helping create the address for the character ROMs. And I'm on one of them right now. And I'll set this up here. I'll just kind of try to give you a look at how this counter works here. I can take a snapshot. And you can see how there's no in. This is the carry input, and this is A in and B in, the two 4-bit words. I have this set to decimal to make it easier. And then this is the output. It's a 5-bit output because the carry out is involved in this, is included in this. So the carry in right now is 0. So the input here, you got 15, and we're adding 15 to these numbers here. 15 and 11 is 26. 15 and 15 is 30. 15 and 3 is 18. 15 and 15, 30, and so on. And now we got some carry inputs. So you take 1 plus 3 is 4, and 15 is 19. Right? 1 plus 3 is 4, and 15 is 19. 0, 3, 15 is 18. See? This guy's working correctly. It's just a 4-bit adder with carry in, and carry out is included in here. So you can see it is working properly as it should. But I'm going to go ahead and move my I'm going to go ahead and move that thing right there up to the next 283 and analyze that one as well. Okay, I've gone ahead and moved on up to the other one here, and we'll put it up here and I'll show you how that's looking. As you can see right here, you got 0, 9, and 9 is 18, and I can just keep on moving this. And now we got 1 and 9 is 10, and 8 is 18. Now we line this up. We got 10 and 15 is 25. Here we got 10 and 15 is 25 again. Now we got 9 and 8 is 17. Then it goes to 10 and 8 is 18. Oh, this one's working properly as well. Now we're back to 10 and 15 being 25. And this is going to be 10 and 9 is 19, and then it quickly switches to 9 and 8 is 17, and then 10 and 8 is 18. This 16 is just an anomaly, I guess, and then you got 19 here. So you can see this is working. Back to 25. So these are not a problem, not an issue. So we'll be moving on to the next thing in line. And just really quick, guys, remember these two muxes where I was analyzing them and it looked like they were missing pulses and stuff, and I went ahead and I replaced both of them and it didn't fix anything? Well, once again, I forgot. You have an enable line. You have an enable pin on these guys, pin 15. And you can see it's not always enabled. So, yeah, I replaced these for no reason, but just wanted to point that one out. So, I forgot about the enable line. Okay, guys, next step in line is this 174 here. It is on the schematic right here. And I think we found a bad part. Well, let me set this down and we'll take a look. You can see, let's, yeah. Right here it's clocking 20, and the output should match, and it doesn't. Right here it's clocking up at 20, and it's down here at 38. Here it's clearly 20, and the clock goes high, and it's 2C down here. That one's kind of hard to tell what's going on. This one should be 08, and it is. $24, you don't see 24 down here at all. 20. Okay, there's 20. 20. See, this thing just isn't quite working right. So I am going to replace this 174 right here. Hey guys, I'm taking a quick look at those 194 shift registers. I replaced that 174, and even though it did not look like it was working right, it did not fix my problem. So I don't know, but I'm looking at this. This is a 194, and I had to pull the data sheet out to fully understand how this thing works. And I have over here, I've got the clock on the top, and then you have two control inputs, which are S0 and S1, and then you've got a 4-bit in and a 4-bit output. How this works is if both S0 and S1 are high, it loads. It loads whatever is on the input to the output. And then with each pulse, see, it's if S1 or S0 is low and S1 is high, then it shifts to the left, I believe. Let me read on the data sheet there again. If S0 is low and S0 is high on the clock pulse, then it shifts left. So it shifts in from the left is what it does. So it'll move, the bits will move to the right is what that means. So, and you can see that here, the bits move to the right. It loads right here, it goes high, and it loads, so they're both 1, so it loads F right there. And then S0 goes low, so it's going to shift that way. So those bits, those 1, 1, 1, 1, F shifts this way, and a 0 comes in over here. Let me see if I can, okay, here's F, 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 F. And then they're going to go this way, and a 0 comes in right here. And then they shift this way again, and another 0 comes in right here. They're going that way. So you can see that right here. It loads F, and then with the next clock pulse, it moves over. You have 1, 1, 1, 1 here, and with the next clock pulse, a 0 comes in from the left and shifts everything to the right. So you only have 0, 1, 1, 1. So now you have 7. The next clock pulse, it shifts again, and another 0 comes in and pushes those 3 1s, one of them out, and now you've got 0, 0, 1, 1, which is 3. And then it happens again at the next clock pulse. And that 3, the 2 ones that are left, one of them goes away, and then 3 zeros are here. So you have 1, and that's that. And then it loads again, and then this clock pulse, they're both 1 again, so it loads 7. So when it gets down to 1, it loads 7 in, and then it does it again. With the next pulse, it shifts it, and you can see how it's shifting like that. And it seems to be only shifting one way. And you say, what is the purpose of this? What it's doing is it's taking the data out of these ROMs and it's serializing it. And it's pumping it out serial. It loads it and it shifts it. Loads it, pumps it. It's turning a parallel into serial is what it's doing. A serial stream of data. It's taking it from parallel and shifting it, pushing it, and making it serial. Serializing it is what it's doing. So pretty cool. Just thought I would show that. And here you can see every time it goes to load, it's just 0. Load 0, and that's because of the screen that it was on. And here, see it here again, it loads F and then it starts pumping it out. And it loads 1. Right here it's got 1 on there, so it loads 1 and when it's already at 1, so it just holds 1 for a little bit. There's no data on the screen right now. There's no character. See here it loads C. C is 1100. So with the next shift, that 1100 goes like this, and a 0 comes in here. Now you got 0110, which is 6. See, that's how this shift register works. It loads it and it shifts it to make it serial. Just thought I would go through a little explanation of how that works and why that is doing that, why that does that. It takes a parallel data out of those ROMs and serializes it. All right. Okay, I just got this running freely now with these 194s, and as far as these go, these are working correctly. But the thing that's curious about this is S1 never goes low. So this is only shifting one way all the time, and it might be designed that way. I think I will try to trigger on S1 going low. Let's see if see, I don't know. It doesn't seem to be wanting to go there. It went low. It looks like it's going low now. Let me gotta sit here and wait for it. See, there it goes. Let's stop it. Now I kind of want to, now it's going to be shifting the opposite way. I'm going to have to put my phone down and really kind of look at this and see if this is working right. Okay, see, now I have a snapshot of this where it's the opposite. S1 is low and S0 is high, and it will go the other way. It'll shift the other way. And right here you can see it loads, both of them are high, so it loads E. So E comes down, now it's shifting the opposite way. So it goes E, C, 8. Well, if we look here, this is E right here. And if a 0 comes in, see, what we were looking at before was the 0 coming in over here. Now if the 0 shifts in here, then this becomes this, which is C. And if another 0 shifts in, then it becomes 8. So it goes E, C, 8. And that's exactly what we're seeing here, E, C, 8. So this is working correctly. Alright guys, I'm looking at this 157 right after the 194s now, and it's up here and it works just fine. It's selecting 0 all the time and it's sending 0 down to the output. This mux will select 1 like that once in a great while. But something ain't right with this board because it's still doing this. So I'm curious as to this select line hardly ever going high. It's just the next thing to look at is the select control line on this guy right here. And it comes from, you follow it down, it comes from this 377, which is in the board right here. That guy right there. So that is the next chip that I'm going to analyze, is this guy right here. And make sure that that is doing what it's supposed to do. So far, this is a pretty good mystery. Everything seems to work. Yet, we have this. We just haven't gotten to it yet, but we will. We will find it. I'd like to reanalyze this guy. Remember I analyzed this and it wasn't working right? I'd like to take a look at that again. Because that was just strange. Maybe I was hooked up to it wrong. I don't know. But it didn't fix the problem. Yeah, I don't know. Moving on. Good morning, everyone. I'm back at this Pac-Man board, Todd's Pac-Man board, and I'm on this 377, which is right here in the schematic. I'm just checking that guy out, and you can see right here I got a snapshot, and I've been going over this and taking various snapshots of it, and this thing's working fine. You can see here, this is enabled low. You got the clock, like a train up here. And then you have your enabled pulses. This is enabled 0. So you got a couple pulses here. And here we have data input and 8-bit data output. And when this goes enabled at the clock pulse, it sends the in to the out. So 5C goes down to the output. And then another enable pulse happens right here, or enable pulse, and the clock goes high when OC is on the input, so 0C goes to the output, and it's like that. I haven't seen anything where it looks wrong at all, so I'm going to call this guy good and move on. Okay, I moved on over to the 273, which is right here in the schematic, which takes data bits right off the data bus and latches them, and what they do is they become character addresses for these ROMs right here, these guys. And if you take, I got a snapshot up here. If you take a look, this is a clear, and it's always high. So rising edge, whatever's on the input goes to the output. So 21, and over here another rising edge with 0 and 0. I've taken multiple snapshots of this as well. This is working just fine. The search continues. Okay guys, I have tested a lot of the stuff in this video section, and I'm having a hard time finding anything that doesn't look right. So what I'm doing is I'm going back to the vertical count, and I'm just going to verify that that vertical count actually is correct by actually analyzing it. And the way this works, I'm going to be on the 8 bits of the counter itself, from 2V all the way up to the sync signal, vertical sync. I'm going to be on those 8 bits, and I'm going to be monitoring the load. I'm actually going to be triggering on the load pin and going out from there. how this works is when this loads, this is the most significant of the 8 input bits, and it goes down this way. So it starts up here, and when it loads, this is all these ones are pulled down to ground, and these bits are pulled up high. So it's 0, 1, 1, 1, and then 1, 1, 0, 0. If you can see that. You know, this guy, let me get something to point with. This guy right here, these are pulled high, these are pulled low. So that's 0, 1, 1, 1, which is 7. And this one is 1, 1, 0, 0, which is C. So every time this load pulse comes in, it will start the count at 7C and count up to FF and do it again. Load at 7C, count up to FF, and then load over and over and over again. That's how that works. So what I'm going to do is I'm going to set up and get ready, and we'll look at that and verify that that's working just like that. Okay, and now here you can see that I'm triggering on the load pulse, and you can see it's coming in right here. This is counting up to FF, and then the load pulse comes in, it sets to 7C, just like in the schematic says it should. And then it's going to count all the way back up to FF and send that pulse again and do it all over again. And if I've got it on delay right now, and I can scroll with it. And if I scroll this way, you can see that count. Right now it just went to 8-0 up to 8F. Now it'll go to 9-0 to 9F. And to A0 up to AF. And B0 up to BF. You can see this is working great so far. C0. And to D0. E0. And to F0. Up to FF, and then it'll load back to 7C. And there it is, back to 7C. And it just does it all just over and over and over again. That's how that works. So and that's that. I mean, that count is perfect. There's nothing wrong with the vertical counts. So it is after that somehow. So I'm just going to have to keep digging, keep looking until I find it. Well, everybody, the whole time that had that weirdness, I knew it was something to do with addressing. I got to looking at the schematic, and I realized you don't need this in. This thing doesn't even have to be there for your fluke tests for the RAM. All this is an interface for your hardware to access the RAM. That's all this does, is it interfaces the video hardware to access to the RAM. So when I realized that, I removed this and I put my fluke on the board, and I did all my RAM checks and everything was good. So I realized right then and there this was my problem. I had replaced that socket, and I am ashamed to say that my own hack work was my problem. So I had to remove the socket, clean it up. I got some RAMs out here. I need to go through these RAMs right here and get the bad ones out of here, because there is at least one bad RAM in this pile. But I got good RAM in here now, and I went through, cleaned this up, beep tested everything. I had to remove the socket. and do my beat tests, test everything out, re-put it in, and now it's looking perfect. So whenever you see that weirdness, and I'd seen that before, once before in a Galaga board set, where you get, in your pattern, you get little squares within the square. It's addressing, and you got your character data like this way, and this way. It's always addressing, but I just did not think that I didn't think that I screwed that up that bad. So I had to fix my own screw up. So this is good to go. I went through and I removed these rams. I mean, I was pulling my hair out. It did not occur to me that my own hack work is what was doing me in, until I realized it has to be this. There's nothing else that it can be, because I went through and I tested everything on this board that deals with addressing the characters or the character data coming out. Remember, the data comes out and it's shifted in these registers here. The bits are manipulated in these right here and serialized and pumped out. But the whole time it was addressing. It was this guy. So, yeah. These are Sprite buffers right here. Like if your sprites, if you're moving ghosts and Pac-Man and stuff have like funky lines through them and stuff like that, you can suspect these dudes right here. That's what these are buffer RAM. So I removed them, and I ended up socketing them and putting the same ones back in the board. So, but it was kind of fun though. We did a lot of testing on chips. We did a lot of analyzing and using the analyzer to see how things work and stuff like that, which was cool. And the whole time it was just this guy. So, well, that's going to do it for this one. Turned out to be repairing previous hack work, repairing my own hack work. We did an awful lot of testing. There was a couple of chips that were bad up here. These two guys right here were no good. Other than that, I think that was it. It was just repairing, kind of repairing hack work, really. So, my own hack work and previous hack work. All right, guys. Well, please give me a like if you liked it. Leave some comments down below. Is there something that you saw that you thought was cool? Let me know. Something you'd rather see? Let me know. Whatever. And it's going to do it for this one. Thanks a lot, guys. See you next time.